Hi class, let's take a look at example 2. Now in example 2, they want us to find the error bound. Technically, if we were to apply, those two methods with n is equal to 6 to the following integral. So let's actually first find m, or the maximum of the derivative. So let me write it as find m, and then technically f of x is equal to the square root of x, then f double prime of x is equal to 1/2 x to the negative a half. And actually, wait, that's f prime. Sorry, I wrote it as double prime. And f double prime of x is equal to negative 1/4 x to the negative 3/2. Now, they're bounding m as an absolute value. So technically, absolute value of f of x is equal to 1/4 x to the negative 3/2. And then we're technically looking at what does this function do on technically 1 to 4. And this particular function, it's actually decreasing, going in this direction actually. So the maximum, it's going to occur at x is equal to 1. So max at x is equal to 1. So therefore, f double prime of x, an absolute value, it's going to be less than or equal to 1/4. Technically 1 to the negative 3/2, less than or equal to 1/4. Okay, so let me do here the error bound for the actual midpoint. So error for midpoint. And then technically this is n is equal to 6. So the actual error, it's going to be less than or equal to the values of m times b minus a to the third power divided by 24, and it's n squared. And let me double check the formula. Okay, so we're looking at this one. And for this particular one, this is going to be less than or equal to, the maximum is 1/4. We're going to be using a is equal to 1, b is equal to 4, and n is equal to 6. So it's going to be 4 minus 1 to the third divided by 24, and then 6 to the second. So this is equal to, this is 1/4, technically 3 to the third. And then 24 times 6 squared. So the error, it's going to be less than or equal to, and let me evaluate this one. Okay, so this is less than or equal to 0.00, so 0078 13. So 007813. You can say that this is 0.0078. So the bound for midpoint, let me just write it as error for midpoint using n is equal to 6 for technically the integral from 0. Whoops, it's the integral from 1 to 4. of the square root of x dx, it's going to be approximately 0.0078. So that's how much error we're estimating to carry if we use midpoint with n is equal to 6 on, well, this specific function. Okay, let me do the second portion of the problem, which is technically the error for trapezoidal rule. So same thing, n is equal to 6. So the actual formula, it's going to be the error. It's going to be less than or equal to our values of m. We have b minus a to the third power, but this one uses a 12n squared. And let me double check. We're using this formula. Okay, so this is going to be equal to our 1/4. We're still going to have 4 minus 1. So 4 minus 1 to the third power over 12 times 6 to the second. And let me evaluate this one. Okay, so the error on this one, it's going to be approximately 0.015625 or 0.01 if I round to 4, 1, 2, 3, 4, 156. So in this case, the actual error for trapezoidal rule with n is equal to 6 for the integral from 1 to 4 of the square root of x dx, it's going to be approximately 0.0156. Okay, that would be for this one. So this is another typical problem. This, it's technically not a common one, but I think I would provide this one just because it could be messy and somebody may accidentally graph it down here, forgetting about the absolute value. Yet again, if it's the same problem, please confirm it with Desmos. But that would be it for example 2.